All right, let's go on to the second and third parts of this problem. You were asked, on average, how many patients are being examined by a doctor. This threw some people off because they assumed, since we didn't say how many doctors there were, that there would only be one. But if Little's law holds and it leads you to conclude there must be more than one doctor, then there must be more than one doctor. So essentially what we've got is, again, we only have one equation to work with, right, which is that our sort of inventory is equal to some arrival rate times some cycle time. And so you're being asked the inventory of the people being examined by a doctor. So we have two different groups again. We have those that are admitted and those that just get a prescription. So the inventory of those who are admitted is the arrival rate of those folks, which we've already said, lambda A is 5.5 per hour. And we've got a cycle time, the amount of time they are at that step, which we're told is 30 minutes, which is just a half hour. And so 5.5 times a half is the 2.75. I can do the same thing looking at the inventory of those at the doctor step that are getting a prescription. That's the 55 patients minus the 5.5, so I got 49.5 patients here. And you've got your 10 minutes, which, as I said, is 1/6 of an hour, so I got 49.5 divided by 6, which is the 8.25. Now, when we're talking about total inventory, then we're going to have to add up these two numbers. The other thing that threw a number of people off was they took a weighted average of these things, which makes sense for rates and makes sense for times, but when we're counting people, if we got 2.75 in one category and 8.25 in the other category, then the total inventory at the doctor's step are being examined by a doctor, which I just write as I sub D. It's just the sum of those two things, which is 11. And then finally, we're asked, on average, how many patients are in the emergency room. There are actually two different ways to do this. One is because we figured out the average cycle time, which is 60.7, and we have an arrival rate, which is 55. That's really all we need to know to come up with an answer to this question, because Little's law applies to the entire process, just as it does to each individual step. So the total number in the system, I'll just sort of write it as inventory again, is equal to an arrival rate, which we're told is 55 per hour, times an average cycle time that we calculated earlier, which is 60.7 minutes, which is something like 1.01 hours. And so the product of those two things is where this 55.66 comes from. The last thing I want to say is you kind of have to think through whether these things make sense. I got 55 people an hour coming in, and they stay roughly an hour in my system. So